Alright, here we are coming down this interesting graph, the greatest integer function. So we're back here on part 2. 7/8, and that is right here for x. And what is the greatest integer less than or equal to 7/8? It's still 0. So now when we get to 1, the greatest integer less than or equal to 1 is 1. So now there's a jump. It jumps up to 1. So can you see from there, let me put the chart alongside, if I do chart sum between 1 and 2, can you see what's going to happen? When I hit 1 1/3, 1 1/2, 1 7/8, 2. So 1 1/3, what's the greatest integer less than or equal to 1 1/3? It's 1. And then when I get to 1 1/2, it's also 1. 1 7/8, it's also 1. But when I get to 2, so these are all 1. And then when I get to 2, it jumps up again. Alright, so the way we indicate that is a bar, because all these values in between these dots would also be graphed. And then at this spot I put an open circle because it jumps up here. And let's try one down in the negative area here. So we have, how about -1/2? So that's the x value. What's the y value? What is the greatest integer less than or equal to -1/2? It's -1. So that would be the same for -1/3, -1 7/8, and it'd be an open circle here, closed here. And this pattern will continue. So, like that. Keep on keeping on. Alright, so it's like the stairway to heaven. The greatest integer function. Alright, when you come to class, I'm going to ask you to actually draw those again and put some aspects on each one, like domain, range, maximum, minimum values. Is the function even or odd? What are the x and y intercepts? Is it increasing, decreasing? Does it have asymptotes? What's its symmetry? So I'm going to go over that with you in class for one of them and have you do it for the rest. But tonight we'll finish up with a little bit about transformations. And transformations are what we've seen before when we were studying the exponential functions and the logarithmic functions. We transformed those, so it's no different. So suppose I have y equals x squared. That's the smiler. And if I add a number to the whole function, it raises it up 2. So 1, 2. And do you recall what happens if that plus 2 hugs the x variable even before it's squared? So this makes it go up 2, but this makes it go to the left 2. You would think it would be right, but left and right are the opposite, so it would move the original one over here. And sometimes you can combine y equals x plus, say, 3 squared minus 1. So that means you take the original smiling function and you're going to move it to the left 3 and then down 1. And you've seen this before. So we'll be doing transformations. The only other one I want to remind you of is reflections. And that is if you had y equals -x squared, that would take this function and flip it across the x-axis. Two ACOOSS. ACROSS across the x-axis. So this is the x-axis. It will reflect across it like that. And if the negative sign is hugging the x even before it's squared, it will flip it across the y. Now on this one, this part will come over here, but this part will come over here, and you have the exact same graph. So it doesn't affect this one, but it will others. All right, that is what we'll be dealing with tomorrow. So hopefully this looks somewhat familiar to you, and you can jump right in with success. All right, carry on.